Hello everyone. So yesterday we had the exam of CSIR June 2025. So this video is regarding that. How was the exam today? Please comment in the comment section below that what is the exam paper, the what easy paper, or if the paper is easy or the moderate or high. So I also give the exam yesterday, but this time without any preparation because I am a little bit busy with my work. So, but according to me, the part A was easy. We can easily because I'm not practicing the part A, and I think 12 to 13 questions I attend in part A, and in part B, I think this part B was थोड़ा सा मेरे को हट लगा, ठीक है? मतलब थोड़ा ट्रिकी या फिर थोड़ा इजी टू मॉडरेट as compared to me without any preparation, obviously. But I have the level of, I know the knowledge level of the question, na? So that's why with the basis of these questions, as for me, that part B is a little bit moderate or high, you can say, and part C, this is if you click the correct question, then this is easy portion. If you other provided that if you have choose the correct question. So this is my point of view of the this CSIR June 2025 exam. So what is your opinion? Please do comment in the comment section below. And in this video, I remember three questions: one from linear algebra, one from calculus of variation, and one from PD. So we can discuss this question in this video. So let's see this question. First, we go to the linear algebra question. This is a 3 marks question. This is a 3 marks questions from linear algebra and very easy, I think. So it says that for a 2 by 2 matrix, these two data are given, that trace of A equal to what? Trace of A equal to 7 and trace of A square. This is equal to 29. Then what will be the correct characteristic polynomial of A? So how can we solve? This is very easy questions. We know that if lambda 1 and lambda 2 are the two eigenvalues of A, then we know that what lambda 1 plus lambda 2 is equal to trace equal to 7. We don't know the value of lambda 1 and lambda 2, that is determinant. The value is no, we don't know, that is not given, but we can find from these options. Okay. And one more thing is that if lambda are the lambda 2 are the eigenvalues of A, then lambda 1 square and lambda 2 square are also the eigenvalues of A square. We also know that. So, but we have to find the characteristic polynomial for A, for the square matrix A. Now we can find, how can we find? So we know the very general form of characteristic polynomial for a 2 by 2 matrix is equal to, suppose, lambda square minus trace of A into lambda plus date of A. This is the characteristic polynomial, we all know that. Now, since trace of A is equal to 7 is given, therefore we can write that lambda 1 minus this is 7 lambda plus something date of this. So we can discard that plus 7 lambda portions. So this is plus 7 lambda, this also option definitely cancel out, and this there is also 7 lambda, so this option is also we can discard out. Now since what we can say that since 7 is the eigenvalue, what happened? So we can find that lambda 1 into lambda 2 equal to if 29, fine. But if lambda 1 lambda 2, if lambda 1 lambda 2 is equal to 29, so definitely there is only one possibility to get real eigenvalue, which is 29 and 1. But if 29 and 1 are the two eigenvalues of this matrix, then in that case trace equal to what? Trace equal to 30. So this is not correct option, that is we can also discard this option. Therefore the correct answer is option B. We can also verify that if lambda 1 and lambda 2 equal to lambda 1 plus lambda 2 equal to 7, then very easily we can take lambda 1 equal to 2 and lambda 1, lambda 2, lambda 1 equal to 1, 2 or 5. So this perfectly satisfied the our question, which is our option, which is given in option B here. So these options may be not in the right order, but this is the correct answer of this question. Fine. Now we get this question. You can also solve any other different way also. So this is just one approach. Okay. So this is a question from PD portion, which says that if utt minus uxx equal to this one, then what will be the answer? So there are, now I think this is the options. So this is also a 3-mark question, and we have to solve the question. So if we apply the Laplace transform to this ordinary wave equation, so definitely we get s square u bar minus s u bar s sorry s u x 0 minus u t x 0. This is equal to d2 u bar dx square. If we apply the Laplace transform, fine. So this implies d2 u bar minus dx square minus s square u bar. This is equal to minus s u x0 means into 1 plus x square, 1 plus x square minus s into 1 plus x u x ut x0 means. Sorry, this is only s 1 plus minus of 1 plus x. So now we can find that u bar equal to u bar, this is the variable. If we take the Laplace inverse in x and s, so this is equal to Laplace inverse, or sorry, 1 by d square minus s square operating on minus n into 1 plus x s into 1 plus x square, and uh, s we can write similarly minus 1 plus x, and d is the standard operator. We know that ddx, fine. D stands for ddx. Now this can we write 1 by, take minus s square common, and 1 minus d square by s square on minus s into, here s treated as a constant in case of this operation, or this dd stand. So this 1 plus x square minus of 1 plus x, fine. So this is equal to, we can write, if the from the first term we write s by s square into this inverse. So 1 minus specifically d square by s square inverse. If we applied, this is equal to first term was 1 plus d square by x square, fine. Because this is plus then dot dot, but we don't need the much more terms. So this is equal to s by s square, 1 plus d square by s square plus dot, implies on 1 plus x square, and this minus also plus, so plus 1 by s square into is applied 1 plus d square by s square into 1 plus x, fine. So this can equal to, we write 1 by s into, so this is first, if operate 1, then this will 1 plus x square, and then d square by x square if operate, then what is will, this will be uh, 1 by s into 1 by s square. So this term also only gives 2x and 2. So 2 by s square, this, fine. And okay, this term, and then this term gives to only this term, because if we operate a derivative 2 times, then this will give 0. So 1 by s square into 1 plus x, fine. So this is equal to actually 1 by s, 1 plus x square plus 2 by s cube, fine, plus 1 plus x by s square. Now if we take the Laplace inverse, then au x inv, if we take inverse Laplace transform, then this will u xt is equal to L inverse of 1 by s into 1 plus x square plus 2 into L inverse, no, 2 by s cube plus 1 plus x by s square. Fine. So this can equal to written as 1 by s inverse Laplace is only 1. So this is 1 plus x square plus 2 by 2 factorial into this is t square and plus 1 plus x into this will again t by 1 factorial and this is only t. So this is equal to 1 plus x square plus t square plus 1 plus x into t. So now u11 this is equal to what? 1 plus 1 plus 1 x equal to t, t equal to t, x equal to 1, t equal to 1 plus this is 1 plus 1 into 1. This is 3 plus 2 which is equal to 5. So this is the answer of this question option D here, that is 5. These options may not be in order but the correct option is u11 equal to 5. Now it comes to another questions which is also a very easy question, comes in calculus of variation. I didn't take any prevision but I'll solve this. I had actually solved these questions in the CSR net. So for alpha greater equal to 0, it is given that j alpha this is equal to integration 0 to 1 y dash square by x to the power alpha into dx, where y1 equal to 1 and this is this. Now what is f? If we consider f equal to y dash square by x to the power alpha, fine. Now what is the Euler-Lagrange equation? EL equation del f del y minus ddx of del f del y dash this is equal to 0. So del f del y means 0 actually, and this ddx of this means 0 means that is actually we get here from here is del f del y dash equal to constant. Fine. So del f del y dash means what? So 2y dash by x to the power alpha equal to constant. So that means we can write y dash equal to some constant c into x to the power alpha. Fine. So if we take like this, right? Some constant into y to the power alpha. Now if alpha equal to 0, then what happened? Case 1. If alpha equal to 0, then what happened? Y dash equal to some constant c. Fine. So if we integrate, then we can definitely find y equal to cx plus d. Fine, for alpha equal to 0. Now if we apply y1 equal to 1, y2 equal to 1, then what happened? Y1 equal to 1 implies c plus d equal to 1 and y2 is equal to 2 implies what happened? 2c plus d this is equal to 2. Now if we this subtract these two conditions, then minus c equal to minus 1, then c equal to 1. Fine. So c equal to 1 means what? D equal to 0. So that means one solution is y equal to what happened? Y equal to this. From this we can get cx means x. So for alpha equal to 0, we get only x. That means option A is true here. Fine. So for alpha equal to 0. Now for if we consider alpha, if we consider alpha equal to 1, then what happened? So if alpha equal to 1, then we find y dash equal to cx. If we integrate, then we can definitely get y equal to cx square by 2 plus d. Fine. Y equal to cx square by 2 plus d. So now if we apply y1 equal to 1, then what we get? C by 2 plus d. This is equal to 1. And y2 equal to 2 gives what? Y2 equal to 2 gives, if we put 2c plus d, this is equal to 2. Now if we also subtract these two, then dd got cancelled. Then what happened? Minus of 2c minus c by 2 is equal to 1 and minus 1. So this got cancelled. No, sorry, minus, not minus. 2c minus c by 2 equal to actually 1 and 4c minus c, 3 by 4c 2c is equal to 1. That means c equal to, we get 2 by 3. Now c equal to 2 by 3 means d equal to what? D equal to 1 minus 1 by 2 into 2 by 3. Means 1 minus 1 by 3 means, uh, is it correct or wrong? If we get c equal to 2 by 3, then from here 2 by 3 into 1 by 2 plus d is equal to 1. 2 got cancel. 1 by 3, 1 minus d equal to also 1 by 3. D equal to 2 by 3. D equal to, C equal to what? C by 2 minus C. 2 to the 4 minus 1. C by 2 equal to this. So y equal to what? Y equal to C into x square by 2. C means 2 by 3 into x square by 2 plus 2 by 3. So 2 got cancelled. If we could take common 1 by 3, then this will x square plus, that means this option B is also correct, and for J1 alpha equal to 1, this C option is not. Now if we consider the another case, which is uh, alpha equal to 3, if alpha equal to 3, then what happens? If alpha equal to 3, then y dash equal to cx cube. Fine. So if we integrate, then we get y equal to cx to the power 4 by 4 plus d. Fine. So now y1 equal to 1 gives c by 4 plus d. This is equal to 1. And y2 equal to 2 gives y2 equal to 2. This gives 2 to the 4, 4 to the 8, 16. So 4, 4c, from this gives 4c plus d. This is equal to 4. And c by 4 plus d equal to 1. If we subtract these two, then we get 4c minus c by 4. 15c by 4. This is equal to 3. That means from here we get c equal to, what happened? 4c minus 16 minus 1, 15 equal to 4 minus 1, 3. Okay, fine. So this implies c equal to 12 upon 15. 12 upon 15. Okay, and d equal to what? D equal to what happened? Or we can also write this 4 by 5. You can write 4 by 5, and d equal to what happened? D equal to 1 minus c by 4 into 4 by 5. 1 by 4 into 4, 4 cancel, 1 minus 1 by 5 means 4 by 5. D is also 4 by 5. Okay, देखते हैं क्या आंसर आता है. Therefore y equal to what happened? uh, c means 4 by 5 na. So 4 by 5 into 1 by 4 x to the power 4 plus d means 4 by 5. What wrong with it? 3 by 5 or 15. Y equal to cx cube. Fine. Alpha and x to the power 4 by 4. Okay, cx to the power 4 by 4 plus d. C by 4 plus d equal to 1, and 4c, 2 to the 4, 4 to the 8, 8 to the 16. 16 by 4 means 4c plus d equal to 4 happened. ठीक है से. Then what happened? 4 for the 4c minus c by 4. 4 common. 16 minus 1, 15c. Okay, 15c minus. Okay. So what is the mistake? In exam, this option is also true. My case, I did the calculations, but I think some calculations mistakes maybe happen because I did the question in the exam, which is correct one. But what happened here? So this also is also correct. Just check once because I think there is a mistake. But in exam, I rechecked all the calculations. So these three options A here, A, B, and D. Three options is are the correct option for this problem. Okay. So in this video, this is the actually class or video. So thank you for watching. And if this video is helpful for you, then definitely give a like to this video, share with your friends, and don't forget to subscribe the channel. Thank you. Let's meet in the next video.